Homework for tonight would be Module 5, Lesson 1. Yes, we are in a new module, which is great. Or 30 minutes of Imagine Math. As always, just keep up with your tracker. That's how you're going to lead to success. Now, today, this video on Thursday, and the activity you'll be doing is the beginning of a new unit on statistics and probability. And today, we're specifically going to be looking at chance experiments. So today, you guys are going to understand probability as the likelihood of an event occurring, describing this likelihood with appropriate mathematical vocabulary. You know you have this when you score 80% or higher on today's quizzes involving basic probability concepts. And our standard now has switched to 7SP, standing for Statistics and Probability, C5, which deals with understanding that the probability of a chance event is a number between 0 and 1 that expresses the likelihood of an event occurring. And we're going to talk about, on that scale, what larger numbers mean and what smaller numbers mean. So I want you guys to just look and listen. We are going to come back to this question towards the end of this video. For a game show, Jared has to choose one of 8 boxes to win a prize. One of the boxes has a big prize, 3 boxes have a medium prize, 3 boxes have smaller prizes, and 1 box is empty. How confident should Jared be that whatever box he chooses, he will win a prize? So I want you to think on that question. And if you need to pause and hear me read it again, or pause and read it yourself, you can do so. But we're going to come back to that towards the end of the lesson. First thing we're going to look at is a video. So sit tight and learn and listen.
What is probability, and how is it related to outcomes? Think about this question during the lesson. Alyssa and Sherry spin the pointer on the spinner and record the color that it lands on. The table shows their results after 100 spins. How can Alyssa and Sherry explain their results? There are 4 possible results, or outcomes, when Alyssa and Sherry spin the pointer. The 4 outcomes are the pointer lands on the red section, the yellow section, the green section, and the blue section. Are each of the 4 outcomes equally likely?
Select your answer.
When it's comparing whether each of these are equally likely, you're looking to see if each of the colors take up the same or equal amounts of space on the spinner. What you're not looking for is you're not looking to see the number of sections each has, but rather how much space each color takes up. And if each of the 4 colors, which in this case they do, take up equal amounts of space, then each of the colors is equally likely to be landed on. Now, that does not mean blue is as equally to be landed on as any color, because blue only takes up a quarter of it. So it's actually less likely to get blue than the other colors, or green than the other colors, or red than the other colors, or yellow than the other colors. But when you phrase it, is blue as equally likely to be landed on as a red, if you're doing a direct comparison, that is a yes.
Each section of the spinner is the same size, and there is 1 section of each color. So, each of the 4 outcomes is equally likely, because the pointer has an equal chance of landing on any of the 4 sections. This time it happened to land on the green section. Each time they spin the pointer, the likelihood, or probability, of the pointer landing on red, yellow, green, or blue is the same. Each of the equal-sized sections is shaded 1 of 4 colors, so the probability of the pointer landing on any given color is 1 out of 4, or 1/4. What is the probability of the pointer landing on each color, expressed as a percent?
So we spent a lot of time recently on percentage. I'm not going to belabor this point. 1/4 is 25%.
Since 1/4 equals 25%, The probability can also be written as 25%. The pointer should land on each color about 1 out of 4 times, or about 25 times out of 100 spins. Alyssa and Sherry's results are close to the expected results.
Now, before we jump into the work for today, I want to go back to the table.
100 spins.
There we go.
How can Alyssa and Sherry...
right here. And I want to explain why this table is not exactly 25 each time. Now, the reason for that is they conducted what is called an experiment. Now, in an experiment, your numbers don't always match what in theory should happen. Because in theory, there should be 25 for each of these. But when they actually conducted the experiment, it was close, but not exact. That is called experimental probability, or you perform an experiment to see what your likelihood is. So that's why this is a little off compared to each of them being exactly 25. And if you guys have like flipped a coin before, right, it should be, you should go 50-50% each time, but sometimes you'll get heads like 4 times in a row or 5 times in a row, right? So sometimes the experiment doesn't fully match the theoretical or what should be probability. So what is probability exactly? Well, probability is the likelihood that something will happen. And it's written as a value between 0 and 1, but it can also be written as ratios or fractions and percentages. Now, the greater the number, meaning the closer to 1, the more likely something is to happen. And the closer to 0, the smaller the value gets, the less likely it is to happen. Now, down here we have what's called a probability scale. You may hear it called a probability timeline, probability number line even, but I like calling it a probability scale. 0 stands for impossible. It is a value that is assigned to something that cannot happen. So, for instance, if we have a regular die, meaning it counts 1 to 6, the probability of rolling a 7 is 0. It is impossible because no matter how many times you roll that die, if a side isn't labeled with 7, you can't get 7. So anything that is labeled with 0 is impossible. Now, I'm going to go all the way to the opposite end. If it is labeled with 1, that is a certainty, 100% sure. So if 0 is 0%, 1 stands for 100% certain. So for instance, if we have that same die, rolling a number less than 7 is 6. Well, I'm going to be specific. Rolling a whole number less than 7, because like 6.8 is technically less than 7. But rolling a whole number less than 7, that's going to happen every time. So that is certain. That is going to happen. It's a 6 out of 6 chance that you're going to roll a whole number less than 7, whether that's 6, 5, 4, 3, 2, or 1. So that's 100%. Now, this 1/2 point is 50-50 shot. Okay? So flipping a coin is a classic example of something that is basically, it's called equally likely or just as unlikely as likely. It's a 50-50 shot. If we have a bag and we put 5 of one color and 5 of another color, that's a 50-50 shot. You're looking for an equal distribution of your options. Okay? Now, unlikely is less than 50% or less than a 50-50 shot. So your name getting randomly chosen in your class is unlikely. You got over 30 kids in your class. You're one kid. The likelihood you are picked out is like 1 out of 32. That's not a very high chance. So that's unlikely. It's unlikely that you'll be collegiate if we say every kid has an equal shot, right? Because we can only pick 2 every month. So it's unlikely that you're a collegiate. But obviously you raise your probabilities by showing 5 promises, right? But you're looking for unlikely being less than 50%. But not 0. Not impossible. Okay? Impossible and unlikely are different terms. Now, likely is a higher than 50-50 shot. Okay? Now, the closer you get to 1, the more likely it is to occur. Just like the closer you get to 0, the more unlikely something is to occur. So something likely could be you getting school pizza sometime during the week, right? That or cafeteria generally serve pizza at least once a week. That's a likely chance. If you put, 7 red Jolly Ranchers and 3 red, or let's say 7 green and 3 red, you are likely to pull out a green because it represents more than half of what is in there. Now, just to drive this point home, how are the probabilities here changing from the spinner on the left to the spinner on the right? Remember, probability is likelihood of something occurring. In the left, this spinner was in the video example. Each of the individual colors, when compared to each other, each had a 1/4 shot of being landed on. This represents like equal likelihood or a fair spinner for all the colors. What do you think is shown on the right? I want you to think about that. Now, maybe to your surprise, or maybe you're catching on, this spinner is just as equally likely as this spinner, because each color is still occupying the same quarter of the spinner. It's just separated into more pieces. But overall, blue is still taking up 1/4 of the spinner, yellow is still taking up a quarter, green is taking up a quarter, and red is taking up the quarters. So these 2 spinners actually, although looking different, show the exact same equally likely probability of landing on the different colors, because it's about the space the colors take up, not how many sections there are. We can split this into a million sections. As long as yellow occupies the same amount of space as green, as does red, as does blue, you're going to have that 1/4 opportunity all the way around. So I just wanted to drive home that point to understand probability isn't just about the number of spaces. It's really about how much it's taking up out of the whole. So I want you guys, you should have, by the way, wrote this down. Notice the icons in the corner. If you didn't, pause it and write it down. And now we're going to look at some examples here. So make sure you write these down. So Kamari will roll a number cubed with sides labeled 1 to 6. Identify the following probabilities. So I have the die kind of faded in the background here. That is a traditional 1 to 6 die that you would use in any kind of game. Now, when you guys are writing probabilities, let me set up my colors here. What you are going to have in your numerator is what's called favorable outcomes. And what you're going to have in the bottom, and I'll just write it as total possibilities. Okay, so you're kind of writing it as a fraction like this. Favorable, that should say favorable. Favorable outcomes are what you're looking for. Okay, what you're looking for over the total number of possibilities. Now, on a dice, if we have 1 to 6, your possibilities are 1, 2, 3, 4, 5, 6. That's it. Right? Those are your choices. Now, rolling a 2 represents one of those choices. So the likelihood it's going to land on what you're looking for, so favorable outcomes here is rolling a 2. That's what you're looking for. There's only one of those out of the total possibilities of 6. 1, 2, 3, 4, 5, 6. Okay? So that probability is 1/6. Now, you can change that into a percent or decimal. I'll just change it into a decimal. It's going to get 0.16 repeated. Now, in terms of the likelihood of this is unlikely. Okay? It is less than a 50% chance. It is less than 1/2. It is 1/6. And if you just think about it in like common sense terms, if you're playing a game and you're rolling a dice and you need exactly a 2, the likelihood that will happen is much lower than like rolling the other numbers, because the 2 only makes one side out of the 6. So this represents an unlikely probability. It's not impossible because it's not 0, right? There's one side that could exist out of the 6, but it's less than 50%. It's pretty unlikely that if you want to roll a 2, you're going to roll a 2. Now, rolling a number less than 7. Well, we already know our total number of possibilities is 6 because there are 6 sides. And less than 7 is all 6 of them. Every number here is less than 7. So that is a probability of 1 or 100%. That will for sure happen, right? You're not going to roll an 8. You're not going to roll a 12. And this can be described as certain. It will for sure happen 100% certainty. Now, rolling a number greater than 6. We know there are 6 total possibilities on a 6-sided die. And there are no numbers that are greater than 6. There's one number that's exactly 6, but none that are greater than 6. So this is 0 or 0%, which is impossible. And what's nice about this vocabulary is sometimes math vocabulary stands out on its own, but these are just words people use every day. Certain means it will happen, right? Like in math context, it means the same thing. Impossible means it won't happen. Same thing in the math context. Same thing with likely. It means it will probably happen, right? Unlikely means it probably won't happen. So these aren't like new math terms like product or quotient. These are normal everyday words we use being applied to math context. All right, we're going to look at a few more examples here. Now we have a different game piece, which is down here in green. And it's 1 through 12. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You guys may have seen board games where the dice, or the dices, if it's multiple, look a little bit different. They may have more than 6 sides. What is the probability of rolling an 11? Well, 11 is here, and that is one time I see it out of 12. Okay, you should already be thinking that is very unlikely. And that actually, if I switch that directly to a percent, gets 8.3% repeating, or 8 1/3%. That is very unlikely. That was less likely than our previous 1/6 because there's more sides. If you're looking for the number 11, you got 11 other sides to compete with. So there's only a 1 out of 12 shot. That's very unlikely. What is the probability of rolling a number greater than 5? Well, we know there are 12 sides. Numbers that are greater than 5. We got 1, 2, 3, 4, 5, 6, 7 of them. Okay, you got 6, 7, 8, 9, 10, 11, and 12. So that's 1, 2, 3, 4, 5, 6, 7. Now, 7 out of 12 is equal to 50. I'll just write the decimal form. So, this is likely, but it's only slightly likely. Because it's likely because it's greater than 50%, right? 6 out of 12 is 50%. So once we go beyond that 50%, it is more likely than not, but it's not incredibly likely. It's just a little bit above 50%. What is probability of rolling a number greater than 12? Well, that can't happen because there's no number greater than 12. So that's 0 or 0%, and that is impossible. Not going to happen. Now, I want to jump back to this original problem. You don't have to write this down, but hopefully you have a little more knowledge to answer this question. Remember, Jared here has 8 boxes. He's picking 1. We have 1 that is a big prize, 3 that are medium prizes, 3 that are smaller prizes, and we have 1 that is empty. Now, we know we have 8 total boxes. It tells us in the question we can also add these numbers and get 8. Now, how confident should Jared be that whatever box he chooses will win a prize? So it's not saying a big prize, a small prize, or a medium prize, just a prize. Well, there's 1 plus 3 plus 3, so that is 7 out of 8. He has an incredibly good shot of getting this prize, which is, as a percent, 87.5%. So he is very likely to get a prize because most of the boxes have a prize. So this is likely. It's not certain, though, because he does have that 1 that is empty. Now, if the question changed a little bit and asked what's the probability he wins a big prize, that is unlikely because there's only 1 out of 8. if it says what's the likelihood he wins a medium prize, that's also unlikely, but it's more unlikely than a big prize because 3/8 is greater than 1/8. It is, if you're just comparing medium to small, those have the same percent chance of happening, 3/8 to 3/8. Okay? But basically what you're looking at is you're looking at this continuum. 50-50% means equally likely or just as likely as not. 0 is impossible. It can't happen. 1 is certain. And then anywhere between 0, greater than 0, less than 50 is unlikely. And obviously, the closer you're getting to 0, the more unlikely it is. And then likely is greater than 50%, but before you get to certain. And the higher you are to getting towards that 1 or 100%, the more likely it is to happen. If you want additional help, because we are starting on probability, and if that was a little bit challenging for you, there is this Math Antics video. I think it's about 12-ish or so minutes. It may be a little longer, a little less. But it breaks down basic probability concepts. We are starting a new unit, so it's important you guys start off strong. So I would highly encourage you to watch this video because it will prepare you really well heading forward. And it will provide you with a strong foundation for the future lessons. So today's goal, you guys are going to complete the quizzes on chance experiments. Use your notes and video as needed. Try that Math Antics video, or you can even try the Knowledge on the Go video if you need more help. Remember, you have 3 attempts for 80%. So if you don't get 80% or you don't do your best the first time, you should be doing it a second time or a third time if needed. And reach out for support. And last thing, this is just a reminder of the coach class schedule, or office hours, I guess it's called now. Please use those as needed and go do really well on that first quizzes for our new unit on statistics and proportions.